Let's go. Good morning, good afternoon, and good evening, wherever you are. It's good to be back with you. Hope you are doing well. You can listen to and watch me on X, the platform formerly known as Twitter. You can also watch and listen to me on Rumble and YouTube. Please like, share, and subscribe because it does feed the AI algorithm. And lastly, please post your comments and questions below. It'd be wonderful to hear from you. It's great to be back with you for this new episode, and let's jump right into it as soon as I bring this up. And here we go. This new article from Business Insider, just a couple days old. Title: This new technology for nuclear power could help fuel the AI revolution, by Lakshmi Varanasi. Like I said, this is just a couple days old from June 20th. Main points of the article here: Swiss startup Transmutex technology reduces long-term radioactive waste. I've seen that in articles, not necessarily articles that I've done here on the channel, but in other articles I read outside, and also previous conversations I've had with other engineers about this being a pain point, or one of the many pain points regarding building additional nuclear reactors here in the United States. And it's also an issue with regards to regulations. Second point: the technology could further entice AI companies to use nuclear energy to power their data centers. Yes, the type of data that's accumulating at right now, and the amount of energy that takes, and then of course the amount of energy that AI is going to take. Yes, you're going to need a lot more data centers, and in order to support the data centers, you're going to need a lot more nuclear energy, because obviously AI, just it's not just magic. It doesn't appear out of nowhere. It needs a support structure, just like all of our technological systems and non-technological systems as well. Third point: only nuclear power will be able to supply this massive energy demand, Transmutex CEO told Business Insider. Yes, that agrees with my knowledge on this particular situation. And I don't think you need a lot of education in alternative energies to understand that nuclear power is going to get you a lot further than, let's say, wind and solar. Right? You're going to get you get a bigger bang for your buck for nuclear power versus the other alternative energies. Let's see here. Article begins: Ancient alchemists once tried transmuting elements, toying with metals like lead to create gold. That pursuit of quick riches has since been abandoned, but scientists are now using a similar idea to level up one of the world's most promising energy sources. Transmutex, a Swiss startup, is pioneering a new method for nuclear transmutation that not only destroys nuclear waste, but can also turn it back into energy, solving a key problem in nuclear production. Right. Yeah. So that's a pain point, right? You have this nuclear facility, it's generating all of this energy, and you get waste from it. And so then the question is, what do you do with the waste? Where does the waste go? In the past, with other technologies, let's say plastics, businesses have developed recycling processes in order to take all those extra plastics, uh, and then recycle them and put them back out to the marketplace. I'm gonna grab some coffee. It's probably one of my favorite things is drinking coffee while I do these in the morning. And for me, it's usually Saturday, Sunday mornings. So it sounds like here, back to the article, sounds like here that we're going to be coming into a similar process. So the same, similar idea, and that is how can we take this waste and recycle it? Um, right now, it sounds like they're going to recycle it back into the facility itself. Are there are there would there could there be other uh, applications for nuclear waste? That I don't know, but I know the only way you get to that is in a market-based system. Article continues here. Scientists have long considered nuclear energy one of the cleanest and most reliable forms of energy production. Okay, so I have a question. If scientists have long considered nuclear energy one of the cleanest and most reliable forms of energy production, if that's the case, then why is it not more common in our society? Now, I get the arguments. Nuclear can be dangerous. There's waste. But here's the other side of that. Science and technology, engineering have advanced quite a bit in the last 50 years, even 40 years, even 30 years, even 20 years. Right? There are new fields that have emerged in the marketplace: software engineering, data science, just to name a couple that completely changed the game as far as engineering and technology is concerned. Right? We know there isn't the way Chernobyl was built, designed and built versus the way nuclear reactors, nuclear power plants would be built today. It's completely different. Completely different. Right? And so if that's the case, why hasn't energy policy, because this is really what this is energy policy that is affected by public policy, and then this energy policy ends up becoming economic policy. Right? Those are technically different forms of policy, but they interact with each other. Right? Nothing is isolated in the real world. And so my point is, why haven't policies changed when science and engineering and technology have changed? Our knowledge of it, our applications have changed. Our ability to be able to design and build more advanced systems. Why hasn't the policy changed with that? That's my question. I don't really have an answer for it. That's my question. That would be my question to a policy maker. Why is that the case? Let's continue with the article here. However, the waste it creates must be stored in deep geological repositories for thousands of years to prevent the environment from being exposed to harmful radiation. Transmutex says its technology can transmute 99% of the world's high-level radioactive waste into new fuel. Right. Right. So there's a pain point, right? A market need, and Transmutex has come along and said, okay, well, we see this pain point. It's been here for a while. We see this need in the market. It's a problem. Yeah, here's our solution. And by the way, 99%, if that's reproducible, if they can reproduce those results over time, it's not always going to be 99%. Sometimes it'll be 95, 96, 97. Maybe sometimes it'll be 100. I imagine this number is the average over time. Well, that's still pretty good. I mean, that's better than zero. I mean, 5% is better than zero. And so this sounds like a great problem to or a great solution to a problem that's been around for a while. And this should satisfy, right? If we're going to follow the science, as I say that in quotes, follow the science, well, here's your data. Let's see what happens. Let's test it out in the market. Now, will Transmutex be able to do this? Who knows? They're dealing with regulations here in the United States. It depends on if currently the Biden administration is willing to work and change regulations in the marketplace that make it more favorable to businesses. Because this is the only way it gets solved. This doesn't get solved by government. This gets solved by uh, by interested parties, stakeholders, a term you hear, by businesses that build this business model to solve this problem. So let's continue here with the article. Nagra, the Swiss agency that manages nuclear waste, validated the claim as a theoretical possibility in a letter to the company last month. Theoretical possibility. That's interesting. All right. So if it's a theory, um, we need to do some more testing. I'm assuming they mean theory as in scientific theory, not as in theory as the general public uses it, because those are two different. The public uses theory in a different way than the scientific community uses theory. In the public, it's used as a guess. In 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 the scientific community, theory is used as something that's already been observed. Let's continue with the article here. Switzerland, however, has pivoted away from nuclear energy. Now, that's a dumb move. That's just dumb, Switzerland. In part because of the safety concerns made apparent by Japan's Fukushima disaster in 2011, which was not a meltdown. That wasn't a meltdown. That was a tsunami, which, according to Britannica, killed about 18,000 people, which is horrible, right? Obviously, that's horrible. But Fukushima, the nuclear energy power plant, um, that was in all likelihood a consequence of the tsunami, which I believe was caused by a earthquake. So a person could definitely, if that's the case, if that's true, a person could definitely criticize the design of the facility. But it's very different from nuclear power itself, right? Those things are different. Uh, and by the way, as far as I understand it, Switzerland doesn't have any, doesn't get tsunamis. I believe it's landlocked in Europe. And earthquakes, I've never heard of an earthquake in Switzerland. Maybe it happens. So, is Switzerland's safety concerns over something of the energy itself, or is it over the natural the possibilities of natural disasters? That's that policy doesn't quite make any sense to me why they would do that. One doesn't, and one doesn't infer the other. But let's continue here with the article. But such disasters are rare, and many other countries, like the United States and Saudi Arabia, for example, are betting on nuclear energy as the most efficient and sustainable option. Yeah, that's those disasters are rare, and in this case, it wasn't a meltdown. It was a meltdown, I believe, after the tsunami, but not before. And so that's an indication of design of the facility, not necessarily the technology itself. Those things are different, like I said before. All right. So let's see where the United States and Saudi Arabia are going. Here's a quote: "To reach our goal of net zero by 2050, we have to at least triple our current nuclear capacity," U.S. Energy Secretary Jennifer Granholm said in May. Well, okay. They don't link to a quote here on the article, which is unfortunate. But I agree with that. I agree with that. That statement. Well, I agree with the last part of it. Triple our current nuclear capacity. I don't agree with net zero. That's not a thing. That's not possible. That's not realistic. That's just not realistic policy. That's for getting votes. There isn't zero anything. Well, I guess there could be no universe, which would be, I guess, technically zero something. But anyway, let's continue here with the article. Tech companies at the forefront of the AI revolution are also turning to nuclear energy to power their vast AI data centers. Right, that's smart. And by the way, I have said in previous episodes, this policy, because these large tech companies, some of them are transitioning their business model to AI. Apple, Facebook, Twitter, AWS, like previous businesses, corporations in American history. For example, John D. Rockefeller, Standard Oil, the company originally started off um, providing lamp oil to citizens, to Americans, and then after Ford came out with their Model T, the Standard Oil companies, I believe they were broken up at about the same time. The Standard Oil was broken up at the same time by the U.S. government as Henry Ford won his court case and was able to begin building his cars and move that product out to the market. Standard Oil changed its business model, or the companies changed their business model, or began to change their business model from uh, lamp oil to petrol. Right. And so it's not uncommon for American companies, especially large American companies who have capital and resources, to change their business models as they move forward. Probably the most stark example of that in modern times is Facebook changing to Meta. And Facebook still exists, but the overall company Meta itself is changing to something else. And Facebook is just a part of that. So my point being that because of the influence of money and the ability to lobby in Congress, uh, we're going to see the attitudes from the press and from journalists on nuclear power and what AI is going to need. And that's going to be influenced by these large corporations. And policymakers will change their attitudes as well because they need money for re-elections. And I don't necessarily think that's a bad thing. I mean, environmentalists should be all for this. Let's continue here. Transmutex CEO Franklin Servan-Schreiber believes the company can help these businesses go nuclear by destroying that long-term waste. Right. Like I said before, that's the pain point. It's a quote from him: "If we know how to deal with the waste, even if it takes a long time, we still know that in the future there's a limit to that waste, which is not going to be a million years. That's the key. In addition, they're going to find new ways to recycle that waste." Again, once regulations are lifted or done in a more efficient way, which I'm not sure current policymakers are capable of doing, but let's pretend they are or they can, new businesses will emerge in addition to Transmutex. Right. And of course, Transmutex, once this business model works, other businesses are going to emerge and compete with Transmutex. Unless government funds them with subsidies and corners the market, and that's the barrier to entry, and no other players are allowed to compete. that's always a possibility as well. A new fuel cycle for nuclear power. Transmutex technology uses high energy subatomic particles known as neutrons to destroy highly radioactive nuclear waste. Interesting. While it can take hundreds of thousands of years for nuclear waste to decay to safe radiation levels, Transmutex says its technology can shorten that time frame to just decades. Right. And I don't know anything about this particular field. This is not my area of expertise, but I imagine if you can shorten the decay rate from hundreds of thousands of years to decades, you could probably change, or you could probably continue that decay rate from decades to years. Right? There's probably a way to do it. That would be an engineering problem at this point. So a couple out of the box thinking engineers are going to have to take the reins on that one. Servan Schreiber says that over time, the system can also turn that waste into fuel that can be used again in nuclear power plants, a sort of nuclear recycling program. Yeah, and I would see that as the prime way of addressing the waste from power plants or from nuclear energy. And then, of course, you would have other uses. Again, I'm speculating there could be other uses for waste as well. But this is a process. It's going to be a process of exploration for at least the foreseeable future. Article quotes here: because you're able to burn waste and release energy, overall the process is very profitable. Right? Yeah, and that's precisely it. Well, that's precisely it. But there's also a second component to that. One, government reducing regulations. Two, does the business model work? And three, how profitable is that business model? You could have a business model where you make no profits, and that's not a very good business model. You're not going to stay in business very long. You're not going to be able to employ people very long. As much as some people on the left may hate it, they have a job because the company they work for is profitable. They may not like that, but there isn't a better system. It is the optimal system at the moment. The alternative is government runs everything and executions follow, i.e., fascism, communism, socialism, all the same thing. I mean, just different flavors, but that's all ice cream. This quote is according to Cameron Porter, a venture capitalist who manages Steel Atlas and is an investor in Transmutex, told Business Insider. Right. The profit motive is the optimal way to move in the market at the moment. Businesses have to make money, which means they have to increase their revenues and reduce their costs. It's not utopia. Nobody claims for it to be utopia, but that's the way it is at the moment. And it meets human nature, or it addresses human nature. That's the thing that Adam Smith got right, is he understood human nature. Karl Marx did not understand human nature. That's the difference between capitalism or market-based economy versus communism, socialism, and government control of the markets, which die out over time. Let's continue here with the article. Nuclear physicists say the company's technology avoids one of the biggest concerns with nuclear energy, that the same fuel used to power nuclear power plants or nuclear plants can also be used to manufacture atomic weapons. Okay. That's a concern. It's a concern government doesn't care about. just like AI government's going to use plutonium to build weapons. That's not going away anytime soon. Quote here, we don't want that to happen. Andrei Afanasyev, a professor of physics at George Washington University's Institute for Nuclear Studies, told Business Insider. Transmutex avoids this risk because it doesn't produce plutonium, a key element for making nuclear bombs. That's good. It's good. Well, that addressed that issue. That addressed that pain point. The technology is also more efficient, Afanasyev said. According to the Department of Energy, spent nuclear fuel can still have about 90% of its potential energy even after 5 years of operation in a reactor. Okay. Maybe that's just, I don't know if you could get that any lower. Maybe that's just a consequence of the technology. Again, technologies are going to have consequences, good and bad. The question is, what is going to be the trade-offs? Is it do you get greater it's like with fossil fuels. Well, some people just want to get rid of fossil fuels right now. They want to shut it down. They want to shut down all the fossil fuels. Okay, well, what's the trade-off? You throw everyone back into poverty? That's the trade-off. The other, if you increase fossil fuels, the argument is, well, this is what happens to the environment. Okay, but that's the trade-off. As Thomas Sowell says, there are no solutions, only trade-offs. I'm gonna grab some water. Let's continue here with the article. With nuclear reactors, you just throw away a big chunk of energy that you could use for everybody, he said. So this technology addresses this issue. They can extract more energy from the existing fuel. Right. I mean, that's basically what everything is, and that's what everything is, and its basic component is energy. Really, this is tending towards the energy problem. Let me say that again. This is tending towards the energy problem. Wars are fought over energy. Basically, everything's about energy. We just use different words for them, different descriptors. Addressing starvation, energy problem. Housing, energy problem. Transportation, energy problem. Everything's an energy problem. In order to get to some sort of Star Trek utopia, and I use that word loosely, and I don't pretend that that's a thing, but to get towards it, in order to get there, you need to solve energy. Will you solve human nature, change human nature? No. Human nature is human nature. But in order to get towards abundance, you need energy. In order to have nice things, you need energy. So any policy that opposes energy, it doesn't get you towards abundance. Again, there are going to be side effects, there are going to be consequences, but it's the direction. Let's continue here. And another thing to extract energy, right? So you're going to use, not just going to recycle the waste, but you're going to continue to use it as energy. That's good. That's good. Next section: AI firms on the lookout for energy solutions. Right. So the AI industry is looking for new, more reliable power sources as the race to develop artificial intelligence ramps up. Right. It's going to be a part of it. Not only are people going to have personal AIs like they have personal computers, you see with computers have gone from the size of a room back in the 40s and 50s and 60s to you have personal laptops, you have desktops. I'm currently in the room I'm in right now. I have two two computer systems, one on Windows and one on Linux. I technically have four computers in this room right now, but two of them I'm not using. But in the system I'm on right now is Linux. Well, I have my work computer in the other room, and I have my phone not too far from me, and I have a tablet in the other room. I lost track of how many computers that actually is. But the point is, you'll have AIs like people have computers, and they'll have a use, some sort of use for them. Does a tablet do this? Is the same purpose, same function as your, let's say your cell phone or your handheld device? Does it has the same function as, let's say, your desktop? Does that have the same function as, let's say, your laptop? Right? They all kind of do somewhat different things, and they have a different purpose. In the same vein, AI, you'll have AI for this, you'll have an AI for that. You could have a personal AI in your phone. If you have a Roomba, right? It's, it's an embedded product, meaning it has software and hardware inside of it, and it does its own thing. It's automated pretty much, but technically it's a computer. Oh, that's a bit of an argument in computational sciences, but I'm gonna grab some coffee. Bit of an argument if it's actually a computer per se or not. That's a more esoteric conversation beyond the subject matter of this video. Anyway, the point being is you're going to be using AI for different things. You'll have AI in new cars. They don't have a new car. Not one of those fancy um, systems, dashboard systems, whereas GPS and you can hook up your phone. I've been and used them as rentals. Pretty nice. But you could have an AI in there, for example. You have an AI when you go to the store. Maybe I have articles coming up about that. We'll see how that works. Again, the point being is you're going to have AIs with different purposes, different functions that you'll use on a daily basis. And after a while, you won't even think about it. You might even have an AI as a girlfriend. I got an article coming up about that as well. Anyway, let's continue on here. Here's a quote by Mark Zuckerberg. Energy, not compute, will be the number one bottleneck to AI progress. That's right. Because in order to get to maximize your compute, you need energy. Again, the foundational technology here is energy. He said this on Dwarkish podcast in April, referring to the computational resources needed for training and running AI models. Right. Like I said earlier, Facebook has become Meta, transition their business model into Meta. They did that. I'm guessing I'm doing a little bit of mind reading, but I'm guessing they did that so they could venture into different technologies, right, to change the perception of their business in order to bring in more investment. If you're Facebook, well, you're a social media site. Why do you need investment for, let's say, nuclear power or data centers? But if you're Meta, okay, so your business model has changed. You have a different mission now as a business. Yes, Facebook is just a subsidiary. We're doing all these other things now as well, like training AI models. Because we need to train AI models, we need data centers. Like I said, I've said a couple times now in this video, the business models are changing. Oklo, a startup backed by OpenAI CEO Sam Altman. Previous articles on, I actually have a previous article on Oklo, is betting on generating nuclear power through small nuclear reactors. Its Aurora reactor can run on spent nuclear waste. Right. So now you're seeing a direct application in the market of what it can possibly do. I don't know if it's actually doing it at the moment. I'd be surprised if it was. But there's an application for the waste. And there's a picture of Servan Schreiber, CEO of Transmutex, right there. Servan Schreiber said nuclear power might be the only way to support the industry's massive energy demands. Yeah, I just don't think you're going to get there through. Well, you're going to get there through. You could get there through fossil fuels. You'll have to do a lot more drill, baby, drill, as some politician said. I can't remember her name. Alaskan politician, I believe. That's said in the past. You're not going to get there through solar and wind, because it's about the technology is about how much energy does the how much energy does the technology produce without with the least amount of space. You know, what gets you the bigger bang for your buck. The issue with solar fields, and I'm not opposed to solar fields, but the issue with solar fields is they take up a lot of space. Plus, you don't just build the solar field, which is a whole conversation in itself. You need to maintain the fields, and that takes a lot of money, a lot of capital. Windmills take up space. Of course, it's a different type of space because it goes vertical. And of course, you need capital and resources to keep up, to maintain wind. And the same thing with nuclear energy. But is the amount of energy you're getting is it how could I put this? Well, before I said you're getting a bigger bang for your buck, I guess that'd be the quick hand way of saying it. I have to think about how to explain that. But it seems to me a nuclear power plant would take up less space and provide a greater amount of energy. Maybe that's what I'm trying to say. So it takes up less space. It's modular, right? So maybe you get more energy per square inch. Maybe that's what I'm trying to say. Or square centimeter or square foot or square meter, or whatever you want to say, or square mile, square kilometer, whatever system of measurement you want to use. Maybe I guess that's what I'm trying to say. More energy per space, let's say more energy per square mile. Since I probably have mostly Americans watching or listening to my stuff. But I could go for most, energy per square kilometer as well. I'll be okay with that. That's fine. Makes more sense to scientists and engineers anyway. Article quotes here: AI requires massive industrial scale amounts of energy. Right. Servan Schreiber said only nuclear power will be able to supply this massive energy demand in a reliable manner. Right. Like I said, energy per square mile. Article continues here: with a technology like Transmutex, only one currently being proposed, the U.S. can build classic uranium-based nuclear plants, such as the Vogtle plant in Georgia, without being burdened with high-level nuclear waste for hundreds of thousands of years. I would say build smaller modular plants. Use all the new tech. Use all of the new tech. That's what I would say. Okay, well, that's the end of the article. So I'm going to move on to my 3 questions. I do in every article now. Question 1. What steps is the Biden administration taking to deregulate nuclear energy or decrease barriers to entry for small businesses? Right. It's good that we have these businesses developing these technologies like Transmutex, but in order for us to benefit as citizens, we're going to need more businesses in the marketplace competing to build a better product at a lower price. And the way that happens is regulations are decreased. That's less red tape. That's less cost for the business, and that'll help increase their revenues, or excuse me, their profits at least. Uh, and they'll be able to compete. And most importantly, customers should be able to choose, right? Uh, so I don't know the answer to the question. I'm just asking the question, and if they're even doing that. Second question: what was the cause of Fukushima? Was it a tsunami? Which I don't. I mean, a tsunami did happen, an earthquake happened, but as far as the meltdown, was it the design of the facility? Again, this gets into the design of it, or a combination of issues plus bad timing. And after the fact, I didn't write this down, but I would add in, was it a Dilbert type situation? Because that's what all large companies, or all companies eventually become Dilbert companies. Question 3: how hard will activists fight back against nuclear energy and human flourishing? Right, because AI is going to change everything if it's not regulated into oblivion, where it is useless, like nuclear energy. I was thinking about this the other day. What would have happened? Where would we be? It's always dangerous to say what if, but sometimes you got to think about what if. Where would we be if nuclear energy was a positive and viewed positively, and people weren't scared of it over the last 40 years? Right? We'd be ready for AI. We wouldn't be playing catch up. We would have been ready for it. And how much better off would we be right now with energy? Right? Again, everything, all policy ultimately is an energy problem. If you live in poverty, that's an energy problem. People who don't live in poverty and people who have money, they have resources, they have energy, they have plenty of energy to choose from. And this is the thing about our technologies, is they make our lives better. I was talking to a friend yesterday, and she was telling me about how back in the 80s, this is before computers were really common, but at the university, they had to wait in line to use the computers. This must have been early 80s. Maybe she was thinking 70s, but um, the computers were much larger and they were much slower, but the research papers that she would write, it made everything more efficient. Because if she would have had to have handed her research paper to somebody else, which they would type out, but because her stuff was complex and hard to understand, her papers would usually go to the bottom and people would write other papers first. And so it took her more time. But because of the computer, even as inefficient as it was then, that made everything more efficient. She wouldn't have to, she could go do something else while the computer was taking care of it. And so that's another aspect of these technologies. They make everything more efficient. If you have the my washing machine is superior at washing clothes, is superior to me in every way for washing clothes. I can never wash clothes as well as my washing machine. Whenever I bring this idea up, this sounds so ridiculous to me, but it's true. It is true. My washing machine is way more efficient at washing clothes than I am. And it saves me time. I have clothes washing right now. Well, I did. It's already over. But before I push play on this video, I threw a load of clothes in. Didn't have to think about it. I could come over here and make this video. and I think it's already done. But imagine if I had to wash those clothes myself. I couldn't do this. So it's more efficient, frees up time, allows me to do other things. That's what computers do. That's what mechanical things do. That's what electrical things do. That's what AI is going to do. And that's the point of all this. It's going to make everything much more efficient. Now, what people use it in ridiculous ways, like people did with printers, where they, um, sit down on the printer with their pants down, take a picture of their ass, and then go ahead and fax that to somebody else. Probably, we're already seeing it. But is that really is that overall, is that really making our lives worse? Is that something that we need to create policy on? To me, that's just a distraction because it's a dumb thing. Yeah, this the trade-off is AI. There's going to be the equivalent for AI. There already is. I've seen some videos, deep fakes and stuff like that. But compared to how much better AI makes our lives, that's the price I'm willing to pay. Our dumb deep fakes for making our lives much more prosperous and giving us a lot more energy. Absolutely. I'll take that. I'll take that trade any day of the week. And that's precisely how policy should be viewed, in my opinion. But that's all I got for today. It's been great to be with you. This is actually my first video back in a few days. I had to replace my my mic. My other mic basically died. I tried doing a few videos and just didn't work, so had to get a new mic. Got one off of Amazon. Basically took them a day to get me my mic, and I'm kind of out in the middle of nowhere. And yeah, a great business model. Amazon's doing a good thing for the world. And with the technology that this mic, all the engineers and scientists who took time to build this mic and built these computer systems, and of course all the people who work at Amazon that got me this mic, the world's definitely going in the right direction. It's not perfect, never going to be perfect, but it's about direction. And that's all I got for you today. I will see you in the next episode. Bye for now.